Problem number 12 says evaluate the indefinite integral. It gives you x cubed e to the x squared over 4 quantity squared dx, and it doesn't really tell you a method, so we need to kind of think about it for a little bit. So I noticed that there's an x squared plus 4 and an x cubed out here. Now that looks like it might make for a weird substitution, but when there's terms like that with powers that are that close, trying to use substitution might be a good place to start. Now, in this case, I do have to make the u equal to x squared plus 4 initially. And if I take my derivative, that's equal to 2x dx in that case. Now, there is no 2x dx outside, so I have to divide this 2 over to compensate for the x dx. However, the other thing I notice is that there is no x squared, or there's an x cubed term out here. This accounts for only one of those x's. So what do I do with this other x squared term out here? Well, I can look here, and by subtracting over that 4, I end up getting an expression for x squared. It just says that it's u minus 4. So now I think I have everything I need to go ahead and start plugging in terms. So what I'm going to do is I'm going to write out x squared. So the x squared term in here, remember this is going to be x squared times x is the way that we're going to treat this. That x squared term is u minus 4. This becomes e to the u all quantity squared. Remember, when you're taking a power to another power, you multiply the powers together. So this really just becomes e to the 2u. And I'm left with this x dx term, and that'll just be du over 2. So I'll go ahead and write that as a 1/2 outside. Okay? So now what I can do is I have a u minus 4 term and an e to the 2u term. So what I can actually do is I can do integration by parts on this. I have a polynomial term and then an exponential term. So if I want to make my u and dv columns, and keep in mind these u's are different from this u. I'm just using this notation because that's the notation for integration by parts. It's a mixture of u and dv. So this u minus 4 is going to be the term that I'm deriving, and the term that I'm integrating is e to the 2u. And what I'm going to do actually is I'm going to go ahead and count for this 1/2. By bringing it inside, it makes it a little bit easier in the long run to keep track of it. Sometimes I forget to multiply through. So instead of forgetting, if I just go ahead and incorporate it in here when I integrate the term, you can also incorporate it in here too if you want to derive it as well. As long as I incorporated it in, I won't leave it out when I write out my final answer. So my terms won't be off by 1/2. So if I go through and I derive this term, so the derivative of u minus 4 is just 1, and then the derivative of 1 is 0. So this does terminate, so that's good. So that means integration by parts is probably the good, best way to go about this. And I'm actually going to write myself a little bit more space so that I can write out the diagonals. When I go ahead and integrate e to the 2u over 2, I'm integrating with respect to u. That becomes e to the 2u divided by 4, and e to the 2u divided by 8. So now I go ahead and do my diagonal terms. U minus 4, that's a plus. This is a minus. This is going to be a plus, but it's the integral of 0. So the integral of 0 is just a constant, so that's where that plus c term is going to come in. So now I can go ahead and just write all these terms out. I have a u minus 4 times e to the 2u divided by 4 minus e to the 2u divided by 8. And then I would have plus c. That plus c comes from this term right here. Because remember, the integral of 0 is not 0, it's plus c. So now what I need to do is I need to go back and factor in all my terms and change it back into x. So this u minus 4, instead of factoring it out, I'm actually just going to go ahead and plug back in for x squared because that's all it was. So it was x squared, e, and I have 2 times u, which u is x squared plus 4, so this is e to the 2x squared plus 8 over 4. Minus e to the 2u, which is e to the 2x squared plus 8 over 8 plus c. So now the question is, does that match any of my answers? It looks like it does, actually. It looks like it matches letter E. X squared e to the 2x plus 8 over 4 minus e to the 2x squared plus 8 all over 8 plus C. So letter E is the correct answer for problem number 12.
The Teaching Center, UF's Learning Resource Center.